fabulous engineers here. We have Chris Swan.
Hey, folks.
And Gary Casey. Hello. And today we are joined by a special guest, Ian Miell.
Hi, Ron.
Okay, if you're unfamiliar with the podcast, we bring on some of our amazing engineers. We have some discussions, maybe some innovative approaches to software development, engineering, and other exciting news that's happening in the tech world. And now we are bringing on special guests to help talk about some of these awesome topics. So last episode, if you haven't watched it, be sure to go and watch it. Pause this one, go back and watch the first one, come back. Make sure to come back though. The last episode, we talked about Kubernetes and why we don't primarily use it here at Atsign. We talked about some failovers, usage prices, and other things, but there were hints of areas in Atsign where we do actually, in fact, use Kubernetes. And today we will be spending some time to discuss that. I believe one of the first things that we brought up was I'm trying to remember which one it is now. Hold on, okay, there we go. I'll just cut that part out. We talked about how we use Kubernetes for the Directory. Chris or Gary, we want to talk about what the Directory is?
Yeah, so the Directory is the place that resolves an Atsign name into the address and port number for the server that corresponds to that Atsign. And so Kubernetes is, in that case, a really good platform for maintaining the service and allowing us to scale that because it's the same thing. And I think if we kind of go back to episode 1 where we were talking about why we don't use Kubernetes for the servers themselves, the heart of that problem is every server is unique and uniquely addressable. And that would mean that everyone would have to have its own Kubernetes pod, and the overhead of pod management would kind of swamp out the size of the things themselves. Whereas the directory, every instance of the directory is giving the same answers to the same questions. So it's much more like a web workload and therefore is a fit for how Kubernetes does things. And that's why we use Kubernetes for that. And then if we kind of poke a little bit further behind the scenes, we've got things like the registrar. And so when somebody comes along and creates an Atsign, that creation process happens on an application that we call the registrar. And as that process wraps up, the automation kicks in to create an entry in the directory and also to spin up the corresponding server for that new Atsign. I feel like with Ian here, though, we should kind of take a brief step back, and it's just recently been the 10th birthday of Kubernetes. We invited Ian here because he's been involved in the world of Docker and containers and container orchestration for almost as long as it's all existed. And I think it would be good to get some of his perspectives on what he sees folk using Kubernetes for, and maybe things he's seen where it's kind of not made sense, but perhaps people are kind of pushing on anyway, or maybe people are figuring out other workarounds like we did when we adopted Swarm for the servers.
Sure, yeah. So okay, so if we go back to the beginning, or if we go back 10 years anyway, I'm a lot older than that. I got into Docker about version 0.4 or 0.5, or around that time, I think. And that would have been 2015 or 16, or probably
2013.
2013, was it? Okay. Yeah, I lose track of time. So the reason I got into it is I read a New Stack article or something, somewhere like that. I read an article about Docker, and Solomon Hykes was sitting there, sitting at a bar, looking very intense. And I read about this thing, and it was sort of like, oh, VMs are too heavy. There's this new thing called containers, and I got interested in that. There were some good links to follow, and over that weekend, when I read that article, I knocked together a prototype single Docker container that contained a 3-tier architecture of the company I worked at the time called OpenBet. And they had a traditional 3-tier architecture, database, application server, web server model, all on tin, not on the cloud. And I worked in third line support, so I got shouted at when things went down, and I had to try and fix them in real time and patch code and so on. Sort of like SRE before its time. And I and developers got very frustrated with the amount of time it took to build environments. And VMs didn't really solve the problem because they were just these monolithic beasts. And so I knocked together this prototype over a weekend, and I realized that I had this way of creating on-demand environments that were A, lightweight, and B, easy to share. So one of the underrated aspects of Docker for me was the layered file system, which meant that our developers in Far East could just download a small patch on top of the existing, builds that they downloaded the previous month, and just get the latest changes that we'd made to the code base. So we built that, made that work within the company on a skunkworks basis. Engineers then, I did a survey of the engineers who used it, and they said they had, they were spending about 20% less time, on toil effectively, and could just get on with their work much more quickly. And I asked to talk to management, talk to the board of my company about getting a budget to extend this across the business. And they said they could fit me in 6 months. So at the same time, Barclays Bank was sort of talking to me about wanted to hire me to be a container Docker expert. And I was writing a book on Docker as well for Manning. So I jumped ship, went to work for Barclays, where they were using Ep.2, which, for those who can remember, was not Kubernetes based. So OpenShift 1 was a product they bought and immediately scrapped, I understand. And then OpenShift 2 was based on C groups and SE Linux, and effectively did the sort of same job as Docker, but in a much less coherent way. And Red Hat wisely decided to dump that. Barclays were in production with OpenShift 2 at the time. And I was sort of brought in to be an OpenShift architect, having never worked on OpenShift before, or Kubernetes. And we upgraded to version 3. And we're in the early stages. It was 3.0 of OpenShift upwards. I think we went live at 3.1. So went into production at 3.1. So then after 3.5 years at Barclays, I then went to another company, another bank, which was less successful at cloud native technologies. I won't name them, but they spent an awful lot of money and produced nothing. And I, along with 200 other engineers, were let go on the same day. So that was another lesson of a different kind. And then after that, I put myself on the market. It's the first time I could just put on LinkedIn, hey, I'm looking for work, and consultancies came forward. So I ended up working for Container Solutions, which is just, as Chris mentioned, has just celebrated its 10th anniversary. And we help companies we help companies move towards cloud native ways of working, which is a surprisingly difficult statement to unpack. But we're an engineering company, I guess, first, but also we've got such experience of seeing companies trying to move from containerized ways of working or non-cloud native ways of working to cloud native ways of working, that we have a lot of knowledge about the sort of what's now called the socio-technical pitfalls of moving in that direction. And so we advise and help companies on that journey, as well as accelerating their engineering learning and development.
So I think you touched there on this thing that's become an industry movement of platform engineering, and I think almost examples of seeing it work, an example of seeing it not work, and lots of effort being expended, and then now it's kind of your job to help people make it work. I sometimes joke that we use Kubernetes as its creators intended, which is on their cloud, and using their managed services, which means that we don't get embroiled in a great deal of ceremony and toil and whatnot around Kubernetes. A few days back, I got an alert from a Kubernetes service that we use to run some object storage, and we've got the sort of Kubernetes autoscaler thing on GKE managing it, and so this is the first time that anything has kind of happened with it in over 2 years, and it was just a sort of temporary hiccup as some stuff was being upgraded and some nodes that should have been available weren't available because I guess the infrastructure was moving under our feet. But I crunched the numbers afterwards, and it's kind of, thus far that service has achieved 4.5 nines without us having to do anything for years on end, and without it costing us a great deal of money, because it's just sat there ticking along, using minimal infrastructure because it only needs minimal infrastructure. But if it needs more, it'll use more, and it's kind of we'll notice in the FinOps rather than needing to actually expend engineer and operations time on doing anything with it. And that to me feels like the perfect realization of the dream that was talked about 10 years ago when Kubernetes launched. However, it feels to me like a lot of organizations are expending a whole lot more sort of heartache and effort on making Kubernetes happen for them.
Yeah, so a lot of the challenge has moved up. So when I started working with Kubernetes, I had servers at home which I hand built Kubernetes clusters because I thought it would be really important to understand how it worked from the inside out. And that, I wouldn't say that was a wasted effort, but I'm not sure I'd make all that effort again if I knew how quickly the world has adopted Kubernetes, really. It reminds me very much, and I think I've written about this in an article. I wrote an article about how, and it was quite controversial, about how AWS is the new Windows and Kubernetes is the new Linux. And the thing that prompted me to think that was that while my colleagues were all saying just use AWS services, they're so much easier, they just do everything for you, I was still wanting to get into the details of how Kubernetes works and so on. And just like we kind of take Linux for granted now, 20 years ago, I was trying to compile USB drivers that didn't crash my machine whenever I pulled a USB cable out. I was sort of doing the equivalent in Kubernetes. But there has been such traction so quickly around Kubernetes as a platform that, I mean, just the other day, for example, I'm working on an open source project excitingly called Compliance Framework. And I'm trying to hand this over to engineers at other companies. And I realized that we had a Docker Compose thing we hacked together to make it work. And I realized that what everyone wants now is a Helm chart. Just give us a Helm chart and we'll figure the rest out. And it's the lingua franca now of moving software products around. that's not the only anecdote. I mean, some of our customers come to us and say, like, we need to move to Kubernetes, and we always ask why, because it's surprising how many people don't have a coherent answer to that. But the answer now coming from more and more companies is our clients expect us to deliver things on Kubernetes, whether that's to their data centers or to their cloud or to across the AWS marketplaces. That's what they expect. It's just like you'd expect a DMG file for a Mac with a product, or an apt package for Linux. Now you expect a Helm chart or something that you can easily deploy on Kubernetes. That's the platform of choice now.
So you touched upon something that. Sorry, Gary, go ahead.
I was just going to ask it. Is it when you say expect? Do they expect things to be containerized, or do they really expect things to be fully Kubernetesized with Helm?
Increasingly the latter. So yeah. Containers for a long time were, the standard unit of currency, or were becoming the standard unit of currency, moving software around. But increasingly, although no one seems to love Kubernetes, people are increasingly accepting it as the sort of standard unit of delivery. And then back to Chris's point, the challenges you get are all the things above that layer now. So no one deploys a Helm chart to Kubernetes and worries that it's not going to work as intended. However, Argo CD, that takes configuration. There are fewer standard patterns, and there are more corner cases to think about at that level. So we've definitely moved up the stack now, and no one even thinks about the Linux kernel anymore. Patching that and so on, unless you're in a very abstruse world.
So I think what you're touching on here is a thing that was articulated by a former colleague of mine, Patrick Kirpan, as installation is a software hate crime. And Pat was a pioneer of virtual appliances. And this was the idea that you could kind of get a bunch of software and stick it together on a VM image and then just deploy that virtual machine image. And so, when Pat came across the notion of virtual appliances, it's kind of, okay, that solves the installation problem, but I think it only solves the installation problem for monoliths. And where we've ended up now with Helm charts, as you're describing, is we've solved the installation problem for distributed systems. And since just about everything in the industry now, especially as people have adopted microservices, is kind of built as a distributed system, it's no surprise that we've all converged on if there's an easy way of packaging up distributed systems to be repeatedly deployed and updated and whatever else, then of course we want that.
Yeah, and I was so as a software engineer who likes writing typically application level software. Kubernetes and Helm are the realization of the dream for me of I want to run everything locally, right? I want the ability to run everything locally using exactly the same mechanisms as they will have when they're running in prod. And this was, a literal impossibility 30 years ago, a nigh impossibility 15 years ago. And now it's totally possible, doable, and in fact, it's easier to do that than it is to do it the wrong way. It's amazing. It's stunning. And I was talking to a friend who is working for a large company, not a tech company, but they have a massively distributed system, And so I asked them, how do you develop? Like, what's your development process? Because I'm always interested in that. How do you actually develop your software and verify it's working before it goes out in the field? I said, well, I just use Helm, and I run all the containers locally. And it was like a no-brainer to him. It's like, why are you even asking me that stupid question? Like, there's no other way of doing it. That is the way to do it. This is the way. And it's just remarkable to me how fully realized that dream is, or has become now. There's always more to do, but it is miraculous, semi-miraculous how the industry, just through a process of continual evolution, has arrived at this place which is unrecognizable and completely revolutionary compared to the past.
So Gary, if we're living the dream, then why do I hear so much whining about quarterly Kubernetes updates and too much YAML? And maybe Ian's actually got a better perspective on that than you do.
I don't know. It's the human condition in it.
Well, haven't we just placed all our difficulties into one box? And then we can all blame that box for being the problem. So I think one of the charges that was leveled at Kubernetes was that it was often used by organizations that didn't need to use it. And I think that is definitely true. There are plenty of applications running out there, there's plenty of companies out there who have, who do one or two things well, who decide, we've got to use Kubernetes. And you've got to ask you have to ask yourself, why bother? What's the purpose of that? And often the purpose is we're scared of competitors doing it and getting an edge on us somehow. Or even we want to retain staff, and and get staff to work for us, and that's what people want to work on. So there's that side of it, which I think there is something there about it not being right. But what you were talking about earlier, Chris, about VMs, monolithic VMs, just make a monolithic VM and run that. That's all very well, but if you work in a bank, suddenly you're being asked questions about how do you know that your VM is patched? What operating system are you running? What else is on that VM that could be problematic? And you've got this potentially quite large thing that you need to then curate. Whereas if you have a Helm chart, the problems are contained within the container, and its runtime is taken care of by ideally some sort of platform team or whatever. But they take care of the safety around outside your container. And Kubernetes gives you a single language to solve a whole bunch of other things. So you've got security, you can limit the capabilities of your containers, you can limit the accessibility of your containers, you can manage with a service mesh if you want to use one, or other tools you can manage who talks to who. Resilience is taken care of for you. That's always a huge thing when you have a new application at a bank. And to an extent, scalability is taken care of, although I think that's very overstated. So I can't remember how we got onto this subject, but how I got
it was kind of the Room 101 thing of we've put everything into the Kubernetes box, but what does that get us?
Yeah. So a lot of the companies who come to us, I'm thinking of one in particular, but this is a fairly common pattern that we hear, is our central IT team cannot deliver environments to engineers quickly enough. So it takes 2 or 3 months to deliver a new platform to our engineers, and they're so busy they can't actually build what they want to build, which is a Kubernetes-based platform. And they also have, particular requirements around security or performance or yada yada yada. And so we come in and we help those companies just very quickly. We don't engage in very long debates about which service mesh is the best one to use. we know where the bodies are buried in those areas, and just kind of help them get on with it. Because the real challenge is integrating it with your particular needs and particular workflow. And the big challenge for those companies is the amount of investment required before you press go. So if you think of it like, well, we can give you an environment in 3 weeks with a lot of effort on our side, or we can give you a factory to produce environments, but that might take 6 months to 8 months, or it might take a year, or we don't really know how long it'll take, but it's going to be a while because we have to sort out all these different things and get the factory going. It's very hard to make that choice if you're a hard-pressed engineer or engineering manager trying to deliver at pace for your development teams. So we get hired to kind of just build that on the side, or build that in the right way while keeping the ship moving. That puts all the problems, as I say, into one box. And so a lot of requirements around will be thrown in at the point you want to make this platform. So say like, oh yeah, we want no application to be able to talk to each other. And oh yeah, we need a process for allowing certain applications to talk to each other. And we need a process around who signs that off. And we want to have a whole CI/CD platform. Oh yeah, and you can't now log into your machines and fix them in real time. You're going to have to wait for the change to roll through and be tested and so on. These are all things that people really struggle with. They really change the way they work. And the difficulties around that, just in the cultural shifts, is really hard to manage. And then you will hear a lot of complaining about it's so complicated. Why can't I just log into the server and change the config and be done with it? These are the big challenges around moving from a kind of traditional way of working to a cloud native way of working. And Kubernetes gets the blame for that, I think.
Yeah. So I would say, sorry, I had a. Maybe this is pithy and maybe it won't work and we can just edit it out. The combination of Docker plus Kubernetes plus Helm plus the ancillary tools that work with that combination is a really, really powerful hammer that does pretty much all the things I want to do. To your point, Ian, the crossing the chasm from how things used to be done to this world, it's a big leap for people to make. But because it's such a powerful hammer, I would say it is much easier for me as an engineer to make everything else into a nail than it is to go around and pick a bunch of other stuff at the hardware store and put together some Heath Robinson contraption of a different tool that will do the thing that's needed. It's just, I just make everything into a nail. And then I don't have to worry about it. It can be removed from the list of things I need to worry about, which is almost endless. But anything that gets removed from that list, frees up engineering mind to do more valuable stuff.
This is a great hammer. Yeah, this is so funny that literally this morning I was working on the project I was describing, and I was using, it was kind of like a buzzword bingo. I was using kind to bring up a Kubernetes API actually. So all you need is Docker on your laptop and you can have a Kubernetes cluster running without it actually being Kubernetes. And using then Helm, although I like to customize, but that's probably another topic for another day. Using Helm and using LLMs to write Helm charts for me, which was an absolute dream, because I basically said, here's my Docker Compose file, give me a Helm chart for that, and it comes up with one. And so all those things that would have taken me a lot of time trying to get the YAML correct, or even look up which fields I needed or whatever. It's all gone away now. It's all, reduced to, hundreds of the time, because I can simply just tell the LLM what I need and it will produce it for me. Then I, at worst, need to fiddle with it a bit and I'm done. Which is so much easier than I remember trying to write pod specs from memory, which I can't believe I ever did, but I did.
God.
Before I realized you could just go to the Kubernetes docs and just cut and paste the ones there, which led me to write to put together the Kubernetes examples project, which Container Solutions curated, which was basically like standard patterns in YAML, which you could then just grab and adjust to your needs.
Where is that project?
It's called Kubernetes-examples under Container Solutions, I think. I can't remember if it's K8s or Kubernetes.
Nice.
But there's also a Terraform examples project, which.
Oh yeah, I found it.
Yeah.
K8 examples, Container Solutions.com. Nice.
Yeah, it's not really maintained now, because you just go to LLM and say, give me some YAML that does this, or give me some Terraform that gives you a VM that I can access.
The LLM got trained on that Container Solutions.
Yeah, maybe, but we put that together because so often on a client, I would be thinking, I did this sort of whole stack of things, service, egress, ingress, blah, 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 blah. Surely I can just write a generic one of these, and then you can just replace the container names or whatever you like, and you're done. And that's, and it was quite a popular project for a while. But yeah, LLMs have completely taken over that.
Ian, you touched upon people's needs around security. And maybe to kind of toe into a future episode of this podcast where we could talk about this stuff some more. Are you seeing adoption of software bill of materials and things like SLSA, which is the supply chain levels for software artifacts, and Kubernetes policy around that?
Well, it's definitely talked about. When I worked at Barclays, I was struck by the gap between what people were talking about in terms of supply chain management and the reality. So I would have people sort of saying to me, "Why don't we just, run these containers through a checker product, and then we'll get a list of all the vulnerabilities, and we'll know exactly where we are." And I used to point out to them that you get hundreds of vulnerabilities coming out. So what you'd need is less that tool, although it'd be useful, but that's not the whole answer. You also need a process around deciding what the criteria for having to fix it is. You need someone to look at anything that goes over a certain score. You also need people who understand the application to know if that vulnerability actually applies to your system. And as far as I can tell, there's a lot of talk still going on about it. And to a certain extent, the industry has moved on, but not that much in 5-6 years. I think certain very specialized places who really, really care about this stuff have got it nailed because they've devoted the energy to it. But a lot of people have bought a service to give them a list of vulnerabilities and haven't actually done much with it. Usually there's some hard-pressed security team in the middle whose job it is to find these things and then go and bug the engineering teams to fix it. That's usually what happens, even though we all know that's not the ideal, but that's still the case.
Okay. And this word, cloud native, we've used a few times throughout this discussion. I've often felt that it has two almost entirely separate meanings. One being the services that are native to a hyperscale cloud provider, and the other being stuff that runs in Kubernetes. And of course, there's a little bit of overlap in the Venn diagram there because there's Kubernetes-based services in the clouds. But how did that come to pass?
So I think cloud native is a way of, for me anyway, cloud native is a way of distinguishing. I mean, there is a CNCF definition, which I haven't looked at in a while, but it was pretty good last time I looked. But basically, for me, cloud native is a way of saying you can run software as though it's natively running in the cloud, but using on-prem, if you like. So a lot of our customers are actually, a surprising number of our customers are running on-prem in their own data centers, and either use cloud for development purposes or to quickly spin up environments, or don't use it at all. But we like to say they're still cloud native if they are doing all those things that used to be called DevOps with cloud thrown in. So CI/CD, automated testing, scalable cloud services where you don't have to think so much about the scalability of them, and using services where you're not worried about the detail of how they're implemented necessarily, but using S3 being the classic example of a service you can just use, TM. You can run those S3 compatible services on-prem. I even saw yesterday on Hacker News there was a Golang SQLite based SQS service products that was there. So for me, cloud native is think of the cloud, how you use the cloud, how you should use the cloud as a company born in the cloud, and then you can run that anywhere on your laptop, in a data center, colo, cloud, or on your own machines in the cloud, or natively with a GKE or EKS.
And I guess we're ending up doing the reverse of that journey in some respects, because Atsign at 5 years old now is a born in the cloud organization, but we're starting to have customer conversations where they want their own air-gapped Atsign environment. And as Gary and I think about how we would go about actually implementing that, then it involves them having a Kubernetes, and we almost kind of presume that, and then us packaging up the directory and the other ancillary components and attaching that to their concepts of identity and provisioning in order to provide them with the missing component from the registrar, which will no longer be there because the registrar is ours and it's running in the cloud. We've been having a great conversation here, and I noticed that Tyler hasn't been able to stay with us throughout, so it probably falls on me then to thank you, Ian, for your time today, and to kind of wrap up with this has been the second episode of the Atsign Engineering Podcast. Thank you, everybody, for watching and listening, and there will be more. Thank you.
Thank you, Chris.
Thanks.
Thank you, Gary.